All right, cool. Thank you. So it's a very plain presentation, but it's mostly content oriented, and I threw it up together very quickly. This is talking about two aspects of Flyte, which one from the contributor side, one from the user side. First, we'll talk about the contributor side, because there are contributors. And this is in cases when Flyte is extremely powerful. There are lots of things it can do, but there are lots of things it still can't. And many of our contributors are trying to add different features. Like recently, few people added supports for TensorFlow, distributed TensorFlow support. One person added distributed PyTorch support. Changong is actually adding SageMaker support and so on. So how does that mechanics, like how do those mechanics work? And there within the company, at Lyft, I mean, some people are using BigQuery. They're using it in different ways. So I just wanted to bring up like what are the different modalities of extending Flyte? What are the different things that you need to be careful about, and why would you choose one over the other? And after that, we'll talk about dynamic tasks, which is also another very misunderstood topic, and I think a less advertised one, but it's really powerful, and we'll talk more about it today. Okay, why extend Flyte, right? Flyte is an orchestration platform. That's what it is. And if it is an orchestration platform, it needs to orchestrate things and infrastructure and make things happen for you. But it doesn't want to solve any of the available open source solutions. It doesn't want to solve those problems on its own. For example, it's not a MapReduce platform. It's not a query engine. It's not a distributed machine learning platform. It enables all of these, but it's not really a platform on its own that allows you to do one specific thing. But for those, we have many other tools in the open source, and they do a great job. For example, we have Spark for MapReduce, we have Presto, BigQuery, Redshift, Snowflake, name your pick, and there are many more coming up to do querying on large amounts of data, and they do a fantastic job with it. And with distributed training, there are lots of new algorithms and frameworks coming up. Some of them do cluster all reduced, some of them do a centralized reduced. They do a great job too. We found one thing missing, and so we built it, and that's an array task. And we'll talk a little bit more about it. That rolls into the dynamic tasks. It's interesting that that's one thing that's not really pervasively available, besides a couple cloud environments. And some cases, users just want to write like simple binaries, right? Like run like a small Python code, or it's a binary in C++ or any other language. And those were the Flyte wants to connect all of these pieces, and it doesn't know all of these pieces yet. So we can teach it that, hey, you can learn about this new piece or that new piece. And it's still a nascent or a young community. We only know a few things. So people who have been offering and adding things, thank you. You're learning more things every day. So let's continue to add that. Okay. Let's talk about two types of extensions that are possible in Flyte. One of them is called the lightweight extensions. These are more like, if you're familiar with Airflow, they're like Airflow-like operators. You can basically write any code in Python, and Flyte can execute it, right? For Flyte, it's Python. And some people actually have asked me this in the past. To extend the Flyte, do I need to do a backend extension and so on? No, you don't need to. It's still running a Python code. You can call any service, do anything. From Flyte's point of view, it's executing a Python code, or it could be Java code, right? If you're using Flyte Java. But internally, it may call BigQuery, or it may call EMR, or it may call any other service, or it may call another operator within Kubernetes. Now, there are restrictions because that namespace and the container that we're running should have permissions to do it. But that's about it. It's like essentially, as long as you can give permissions, you should be able to do that. And there are two examples to do this. We already have in FlyteKit. One of them is a sensor task. Sensor task
Hey,
is.
Kumair,
Hey,
I think the slides might not be showing because they're in full screen mode or something like that. Because we just
nobody
see
said
the
that. Oops,
the
sorry.
initial slide. Thank you so
Do
much.
you? Oh, that's sorry about that. I didn't know Zoom works like that. Sorry. What can I do better with this then?
I think it's the share full screen versus sharing a window.
Maybe, I don't know what this does. I think this is better, right? You can see this now? It's good enough. Do you guys see the screen? Thumbs up,
We
thumbs
just see
down.
the title slide, or at least I do just see the title slide.
Okay.
And it's in the non-presenter mode, so it's basically like.
Thank you for bringing it up, though. And I'm really sorry. I'm trying to see. Maybe I'll just share this. How about now?
Yeah, that's a lot better. Thank you.
It's a lot better. Okay. I don't know what happens if I make it a full screen. So yeah, the previous slide where I talked about was just a high-level slide. This slide is talking about what FlyteKit and raw containers can essentially execute any code that's up there. So if you, sorry, I lost my train of thought. So there are two examples available that we ship with in FlyteKit, but those are mostly examples, right? The reason why we don't ship with like tons and tons of them, because first of all, nobody's written them, and even if people are writing, they're writing it within their own libraries, and they don't feel like sharing them with other people, and it's not required to share, right? It's like these are simple Python extensions that you can write, and they are essentially, in my terms, they are decorations in Python that you're doing for simplifying your tasks. But we thought sensor and notebook are generally applicable and useful, so that's why we ship them. A sensor task is essentially when it runs, it can wait for something to happen. In this case, and the ones that we've shipped with are two things. I think wait for a file to land in one of the data stores like S3 or GCS or Azure file system, or it can be a partition to land in a Hive metastore. If any of those things happen, then it returns a yes, otherwise it just keeps unfolding. From Flyte's point of view, it's running a Python container. So it's just waiting for that container to exit as a success or a failure. The second example is a notebook task. So we recently announced these. We actually had them for a while. We just recently pushed them out. These allow you to run paper mill notebooks with a slight modification. So we actually take the entire notebook and execute it by injecting inputs into it and reading outputs from the notebook. So let's say if you're a data scientist and you prefer writing everything in notebooks, you can write everything in notebooks and just drop the notebook into Flyte, wrap it with a method outside the notebook, and it will execute the notebook. But again, the reason why notebook tasks are not backend tasks is because for us, we are executing a container and it chooses to execute the notebook. Okay. Internally at Lyft, actually, there's a team that runs BigQuery ETLs. And what they have done is they wrote it in Python itself. They didn't, like, they were mostly data engineers, very familiar with Python, did not want to extend the backend. So they just wrote a small ETL stuff that runs on BigQuery. And they did it in Python, didn't even tell us, they have not shared it. It works fine for them, right? The mental model that I like to say that this is like Airflow. You could actually bring all of Airflow operators to Flyte into the Python world and just run them as is. The Airflow operators are limited where they don't take inputs and outputs, but you could use the inputs as config in Airflow and take the outputs as the XCOM, the Airflow producers. So that's how, the lightweight extensions. And how do you do that? I don't know if everybody's looked at the FlyteKit Python, and I'm just talking about FlyteKit Python. Nelson or Gleb might give a better detail about FlyteKit Java. But in FlyteKit Python, there is a base task called SDK task. This is essentially mirroring the Flyte ideal or protobuf concept of task template. It's just some decoration on top of task template. And you can represent any task in SDK task. But when you are extending FlyteKit only to perform new things, you should extend something called as the SDK runnable task. What the SDK runnable task does is essentially allows you to, it automatically injects the container that you're in into the task context. And it is the task that will get executed. So all the input output marshalling and all of that is handled in the SDK runnable task. An example for this, like both the sensor task and notebook task are runnable tasks. I have links to them. The highlighted portions are links to the code themselves. And so go and check on it, ask us questions if there is anything. But this is a good starting point. And examples of this is the Python task is an example. It's an SDK runnable task. Right? It's just a decorator on top of SDK runnable task, and it executes Python function. It's a misnomer. It shouldn't have been called Python task. It's a task. It can be any language. Doesn't really matter. Right? Okay. Why would you not choose to do this always? It's super fast, really easy to go with. You know, you can start today and probably have 10 tasks written today and go out. The reason would be, and at Lyft, this happened to us, potential of resource leak. Let's say you launch a data flow job and it runs fine, but you forget your user aborts, or maybe the container crashes, or you lose the machine. So in any of these scenarios, you've lost that reference to the job in Airflow, unless in Dataflow, unless you have a idempotent mechanism to retry and recover that job. It's very hard to reclaim the job. And so what happened in the past at Lyft is we kept on running something, and that costed us a lot of money. In these cases, it's a little hard to, basically, the cleanup process. Second is there's very low visibility and debugging information directly available through the platform. You do get logs, you do get metrics, but you don't get specialized visualization in the UI, right? Yeah. For example, if you've looked at the Spark task, you get a link in the UI that shows you a link to the Spark history server, or the Spark driver log specifically, or the Spark executor logs. You don't get all of that when you're using Python tasks or extending only Python tasks. And there is recoverability from crashes, so that means partial state recovery. So let's say, assume you launched a job, but we lost the container, and we recovered the container somewhere else. Flyte would do that if you have retry set, and let's say you have infinite retry set. So it will just keep on recovering. But you won't be able to just know which job you had launched unless you build that logic into the system, into your task, and that's quite a bit of work. And it's not, I've seen most commonly that many users do not think about failure scenarios this way. And that's where it becomes hard. Also, like, let's say you want to share this task with everybody. You could write it in FlyteKit, and then other people would get it. But we have to write it to FlyteKit. Secondly, you want to have some common configuration. Let's take another example. You have Spark, and you want to always inject a Metastore configuration for Hive so that you can know what tables you have from Hive and use them. It would be very hard to do that in a common platform-specific way for the entire, for every user and the entire community itself. And then eventually, resource pooling is also very hard. You can only provide resource pooling within Flyte at a task type level. So for example, you say, I want only 10,000 Python tasks to run. That's it. But you can't say now 10,000 Python tasks, and within that, only your specific task type to be limited. That's not easy. We actually can support it, and we would be working on it next year. But yeah, at the moment, it's not too All right. So then what is the other alternative? The other alternative is to extend Flyte Backend. And I always recommend starting with Flyte lightweight extensions, because that's the best way to vet your idea, make sure that what you're thinking is right and the interface is clean and correct. And then once you feel a little confident, maybe you've spent like a week or something, come and extend the backend. But in some cases, you have to extend the backend. So we'll talk about those cases. So the Flyte backend is extensible. It's essentially what you're doing is you're adding bits into the Flyte propeller, which is the engine that runs Flyte tasks. You're adding bits to it, and you can extend it. We have created an interface that allows you to extend it. The benefits of that are that you can actually teach Flyte to do anything, create a new execution cluster and execute it, call a service or run a container. And you could thus run a container in any container environment. One of the questions that I think Jeev asked me recently is that why does the base container look different from a pod? And the reason is because container is more portable than a pod. Pod is a very Kubernetes specific concept, where a container is, you can run it on Mesos or on AWS batch or whatever. And we have seen cases in which Kubernetes doesn't scale enough, and we find it better to actually schedule the container onto some other places. And these have to be simplistic containers, because you cannot actually have a volume and other things attached to it, and that makes it heavyweight. That makes a pod heavyweight. When you write a backend plugin, you do get automatic UI visualizations. You get resource pooling. It's automatically available to all different languages in that Flyte is written in, and you can provide default configurations. Like recently, we added blanket tolerations. You can do that for backend task. And then I talked about the metasphere. Examples of backend tasks are Spark. It actually dynamically brings up a cluster and tears it down. It injects some common configuration automatically. It monitors and makes sure that the task works. SageMaker allows you to launch training and inference jobs directly into AWS SageMaker. So you could do that for CloudML, Google CloudML if you want. Presto and Hive, we use this a lot at Lyft. So we can run directly a query in Presto and return a data frame. And we do resource pooling on Presto and Hive. And then array jobs. We'll get into array jobs a little bit more, but array jobs that we run on AWS Batch actually at Lyft. You can also run them on Kubernetes, and we are improving that support every day. But we run about array jobs of in the order of like 5 to 10,000 containers per job. And for that, we have seen Kubernetes doesn't scale as much. So we are making Kubernetes scale every day. All right, so what's the anatomy of building a backend task? So step one is you actually define your specification for the task. And you can do that in any language. We choose protobuf for most of our examples because that's the thing that we are most comfortable with. It's easy. We have tooling for it. So you guys can choose protobuf, but if you don't want to do that, you can use OpenAPI spec, you can use just strings, tribal knowledge, either ways, right? Any of that is fine. You go ahead and implement the backend Golang extension, which is built on top of PluginMachinery. And we can walk through PluginMachinery, but it's better to look at that. It's available in the Flyte plugins repo. It will eventually move into Flyte Ideal. We're keeping it there because as we find any issues and any things, we fix it immediately. We have not found recently, so as it gets more stable, we'll move to Flyte Ideal. And then step 3 is actually defining the thing that the users interact with. That's in Flyte Java or Flyte Python. The reason why we just don't really write protobufs is because this is where the user delight comes in, right? User wants to interface with the system in a much nicer way. Like by writing their Python code and putting a small Spark task decorator on it is much nicer than like thinking about entire Spark and doing clusters and so on. So come up with meaningful differentiation within the interface, and you can build really pretty interfaces in Flyte. An actual example implementation is what I put here is I think PyTorch operator. It gives you the entire gamut of all the pieces that you have to implement and how did this user went about implementing the backend plugin, the specification, the Flyte implementation, the example, and the docs. Right? So it's all of it. And there is if you want to really try it quickly, there is a prototype repo called Flyte Plugin Example. It's a standalone Flyte propeller backend, Flyte kit, everything together. So you can just clone it and hack it and start getting it running very quickly. Okay, so the thing that makes this work is PluginMachinery. It's very simple interface. It consists of 3 methods. Handle, abort, and finalize. Every time a plugin runs, we actually call the handle method. Handle method is called n number of times till handle returns success. Once it returns success, we can call a finalize. If some event happens, like another node dies or an external user clicks abort, then we call the abort method. And after the abort, we also call the finalize method. So this is the core plugin interface. Every type of plugin interface is defined on top of this plugin interface. What we did is we also provide a very simplified state handling system in the plugin interface. So for example, let's say you call some remote service and you want to store the ID and a couple other bits of information. You just write it as a Go struct and return it back to Flyte Propeller. Flyte Propeller will automatically store it. Next time when it calls handle, it will return that value so that you can reuse it. If you know anything about Kubernetes operators, they are not exactly once. They are at least once. So they'll keep on calling the handle loop multiple times. In Flyte Propeller, we have optimized that. We try to reduce the total number of calls, and we kind of guarantee in many cases that we'll only call you once if you want that. And this prevents, like, let's say you had called a remote service and you launch a query. You don't want to be called again and launch the query. So you don't want to do all of that crazy handling within yourself. So we have simplified. But we still realize that there is a much nicer interface that we can create for Kubernetes. So we created a simpler interface for Kubernetes. We just implement even one method, how to construct the object and how to analyze the status. And the third one is it's coming soon. If you want to call any web service, how do you simply do it? Okay, if you want examples of where you can write one, all of these are ones that people have talked about, asked about. So please help us write. I will help you in any of these. Also, a Dask operator, array operator, EMR, BigQuery, Dataflow, and they are available as Kubernetes operators. So it should be really straightforward to add. All right, let's do a time check. It's 30 minutes. So we could quickly, I think it will take 5 to 10 minutes more to talk about dynamic tasks, and then we'll open up for questions and other things.
Okay, then we're on a 40-minute limit.
Oh, really?
Remember?
Oh, okay. All right, so then I can finish in 5 minutes. So dynamic tasks is a misnomer, or it's not completely understood. Dynamic tasks allow you to alter the shape of Flyte workflow, right? You can just dynamically generate a workflow, or you can dynamically generate a set of tasks that you want to run, or you can dynamically launch other workflows. And it's simply constructed. We are actually working on improving the construction itself, like in Flyte, like the user delighting experience. I don't think we have the user delighting experience here. We're trying to work and improve on that. This might be a little light, but what this is essentially you write a Python function and you put add dynamic task on it, and you yield the tasks that are to be run. The rotate task itself could be any task. It could be a Python task, could be Hive task, could be sidecar task, could be Spark task. We don't care. Like what essentially is happening in the backend is, we'll talk about it actually after going through all the examples. The second case is selectively launching some launch plans. It's the same dynamic task. It's exactly similar construction. But what in this case I've done is I've created a launch plan and yielded the launch plan. And this launch plan was dynamically created. This launch plan was created statically, and it was not. So this allows you to selectively launch any launch plan, and so you can put complex conditionals to decide what you want to execute. And this makes it really straightforward to execute. The third one is actually generating a dynamic workflow. So workflows in Flyte, as you know, you have to write them using the DSL, and they automatically get registered. But there are some cases in which you don't know the structure and you want to change the structure or add new nodes and so on. Dynamic tasks allow you to do that. And this is an example of actually creating a new workflow. And all of these examples, by the way, don't worry, they are in Flyte Cookbook. So Flyte Snacks Cookbook / Cookbook has all of these examples. Please go through them. But this allows you to generate a dynamic workflow. Okay, so I won't get more into detail about the various use cases, why you want to do them, because what we have learned is users have amazing sets of use cases, and I can't really document all those use cases, but I'll tell you how it works in the back. So Flyte Propeller, when it's executing a node, and a node is a super concept of a task, right? It encapsulates all various execution retries and so on. So when it's executing a node, it looks for one of three things. It looks for a success with results of that node. So when a task execution completes, it returns results, and it looks for, or it looks for a failure. And the failure, that's how we capture the failure information in the UI. So you get the log trace in the UI and all of that. That's because we look for a failure. Or the third option is we look for a success, but not results or an output, but we look for a thing called as a future file. And I should have put a link to the future file specification in Flyte IDEA, but I will do that after the call. So that allows you to essentially tell Flyte Propeller, by the way, I'm not done. I think I processed whatever I had to, but do this now. And what Flyte Propeller does is takes that future specification, and it follows a format. It's essentially a workflow specification, and Flyte Propeller dynamically compiles that workflow. If the compilation is successful, then it starts executing it like a normal nested subworkflow. If the compilation is not successful, then you get an error at runtime. And this is the caveat of using dynamic tasks. You get errors much later in the game. You will get errors at runtime because we don't know what type of construction you do. But it's really powerful, right? With great power comes great responsibility. So we have not advertised this feature a lot, but we will be advertising more and more of this because we think we are absolutely stable with this. Almost 90% of workflows at Lyft have some sort of dynamic tasks in them, which makes us extremely confident that this thing works and scales beautifully. So if you have use cases, let us know if you're using it. The interface is a little, I still feel it's not perfect, and we are trying to improve it. And that's where Flyte Kit enhancement that he talked about a few weeks ago is coming out soon, and the proposal and everything. He even has a prototype for it. We'll be sharing that. But a quick overview of dynamic tasks again, or a recap. You use dynamic tasks when you don't know the structure of your workflow. That means you can't define it ahead of time. Today, you use dynamic tasks also if you want to launch a large array job. That means you want to launch 10,000 copies of tasks, and you want data partitioning between them. And you use dynamic tasks if you want to dynamically generate a workflow. So these are the three options, right? And any task can be a dynamic task, and any task can be the parent dynamic task. That's my presentation. Any questions? That's a lot of content. It's all, the slide deck is in there, but you know.
How does it work if dynamic task creates a workflow and this workflow has a new input?
A new input? What do you mean?
Like a new, like something that didn't exist before. Can it happen?
Yeah, so it will fail compilation. So the interface of the newly generated workflow has to match the encapsulating tasks interface. And that's like the enforcement that happens at runtime. So we compile the dynamic task parent, right? The node that actually generated it with its interface. And now whatever it generates has to abide by that rule. And so if you generate something that generates one more int, we'll say, oops, that doesn't work.
Oh, okay.
I have a question.
Yes.
So we've used dynamic tasks at Freenome, and we've used it mostly for running multiple sort of Python tasks.
Yeah.
One thing that we really like is sort of the modularity of Flyte, being able to even compose sub workflows into larger workflows or super workflows.
Yeah.
Unfortunately, I've noticed that sub workflows don't play very well with dynamic tasks, so you can't do a for loop over for loop and launch multiple workflows of the same kind using a dynamic task. It fails with a node ID error or something related. Is that something that you guys are aware of? And is there a plan to support being able to launch multiple instances of a given workflow using dynamic tasks moving forward?
Absolutely, but I think Yi was nodding his head, so I'll let him answer this question because he's been digging.
Oh
into
no, I
this.
think you can answer. But yeah, go ahead.
No. I don't know if this problem exists. I have actually my personally don't know. Yeah. So.
I think this will go away. I'm pretty sure this will go away with Anand's node-to-node relationship change.
Oh,
The reason is because when you run the same workflow multiple times, the string ID, the node ID, which is supposed to be unique, ends up being not unique, and then that becomes a problem. But with the node-to-node relationship, we're changing how we compose or construct the actual string.
Yeah, it's pretty close to getting done. I think we talked about it in the last meeting, but yeah, Anand's not here today. He's working on it. And
I'm afraid our meeting is going to be ending for us, like it or not.
Can we just restart another meeting and just open up for questions? Anybody who wants to join?
Yeah, I'm happy to do that.
Just rejoin, right? This meeting. Can we do that? I don't know. So.
I haven't tried it, but I assume there's no reason why it shouldn't work.
Yeah.
So, all right, then we'll preemptively end the meeting right now and then rejoin the same link.
Yeah.
If you want to follow up with
Yeah.
questions. Okay. So I'm temporarily saying goodbye. I hope to see you all in about a minute.